Alrighty, we're going to get started here. The first question is the measurement 1685.70 milliliters a length, volume, or a mass? You can put L, V, or M in the chat. Well, what type of measurement is that? We got a little bit of a mix. ml is milliliters. So that's going to be a volume. If it were a mass, it would be grams. Okay. Question 2. How many significant figures are in 1685.70 milliliters? We got a mixture of 6s and 5s. I figured that would happen. There are six sig figs here. Ooh, that's a tongue twister. This 0 is significant. So remember, zeros at the end of a decimal number are significant. Stress on the end, all right? Now, how do you write that same measurement in scientific notation? So you don't need to round here. I didn't say to round. So you want to use all of the significant figures in your coefficient. That's your coefficient. Since all of the numbers are significant, all of the numbers are part of your coefficient. So it should be 1.68570 times 10 to the third milliliters. So your coefficient contains all sig figs in your ordinary number. Questions on those? Okay. So we'll do some review of the addition and subtraction and stuff like that next time, or just for exam review, one of the two. We don't have time to do all of that today. Today we're starting chapter 2, which is on the metric system. I uploaded the link to the first video, which covers the metric system and doing conversions. We're going to do a lot of practice problems today. I am hoping that you had a chance to take a peek at the video. It was about an hour long. I'm going to try to keep all of them to about an hour. It might be an hour 15. I know y'all have other stuff to do, and I don't want to be talking for that long. So if it's more than an hour or so, it will probably be broken up into 2 videos, like this chapter. With that said, I'm going to say it now and at the end of class. You will have your first chapter check-in due on Sunday. There's no mastering chemistry due this week because we're not finished with chapter 2. though I highly recommend that you start it this week. You also have a syllabus quiz which has been posted already to Blackboard. The syllabus quiz and the Chapter 2 check-in are both due on Sunday by 11:59 p.m. Eastern. Okay. Wanted to say that at the beginning. I'll catch the latecomers at the end. So if you're here the whole time, you catch it twice. And that's all right. Also, honesty hour. I had lunch literally right before class. I burned the tip of my tongue because I couldn't let my quesadilla cool down because I was hungry. I might struggle with some words. Might sound like I have a lisp. I'm sorry. It's real life struggles over here. Okay. We're going to start off kind of easy, smooth, with the fill in the blank question. There is a table that I showed you in the recorded video that talks about physical quantities, the basic units that those quantities are measured in, and their symbols. Take a second if you have it in your notes. You can just pull up that table. If you don't, you can try to fill it in. Otherwise, in 2 minutes, I'm going to fill it in. So I'm going to pause the recording, turn off my mic. I'll let you work for a minute, probably not 2 minutes, and then we'll get back to it. Okay, I'm going to start filling these in. So make sure you have this in your notebook because you will need to know these. The basic unit meter is for the physical quantity of length, and its symbol is a lowercase m. For volume, the basic unit is the liter, and its symbol is a capital L. The symbol G is for the basic unit gram, and that's for mass. And time, we use the second, and its symbol is the lowercase s. That's just something you're going to have to remember. No real good way to, make it fun and easy. I apologize. So are we good to move on? Okay. Now we're going to get to the metric system and looking at this table which I introduced in the recorded video. The metric system is very easy to use once you get the hang of it. You've got a basic unit like the meter, gram, liter, or the second. And to that, you add a prefix. The prefix will either increase the value of that basic unit or decrease the value. Let's say that I have a gram. If I put centi in front of it, then that means that I have 1 times 10 to the minus second grams. The symbol for that would be a lowercase c and a lowercase g. If I were to write kilogram, that's the same, you look at the chart, as 1 times 10 to the third grams. And its symbol is a lowercase k with a g. Now I want you to try. If I have a picogram, what is that equal to? Right. 1 times 10 to the minus 12, and don't forget units. Our units here are grams. What we've been doing is writing unit equations. If I have 1 centigram, that equals 1 times 10 to the minus 2 grams. If I have 1 kilogram, that's 1 times 10 to the third grams. If I have 1 picogram, it's 1 times 10 to the minus 12 grams. These are all unit equations. And they relate to two units together that are either in the same system, like, both in the metric system, or you can have metric English, things like that. But it's just a definition of one of this equals something else. Let's keep going and trying to write these unit equations. I want you to try these 3 problems. Write a unit equation that describes the relationship between the centimeter and the meter, the kiloliter and the liter, nanogram and the gram. I'll give you 5 minutes to start this, and then I'll check in with you. Alrighty. Let's get started. I will warn you, there may be some features from baby Hefner. He's still pretty fresh, about almost 3 months old. And he's still pretty attached to mama. So if you hear a little wah or something in the background, nothing's wrong. I'm just being Dr. Hefner and Mama Hefner all at the same time. So give me a little grace. We're going to work it all out. Thank you very much. For the first one, we've got centimeters and meters. If we start with 1 meter, we have 100 centimeters. If we start with 1 centimeter, that's the same as saying 1 times 10 to the minus 2 meters. That's 2 unit equations that describe the same relationship. This one you can get directly from the table. This one up here, you have to flip the sign for the scientific notation. Because remember, 100 is 1 times 10 to the 2. It's the same thing. So talk to me about the first one. Did we get one of these 2 answers? My guess is that you probably got this one if you got it. How did we do? Okay. Because writing unit equations is really important. If you can't write a unit equation, you won't be able to move on and do the unit factors and solve problems. Somebody want to share what they got for number 2? And if you got stuck or you're like, I don't get it, that's participation. You can say that too. If you're stuck, somebody else is probably stuck too. Okay. Thanks for sharing, because if you're stuck, the rest of the class is going to be a struggle. So let's go through and do this. If I write out the word kiloliter, it's made of 2 parts. We've got the prefix, and then we've got the basic unit. The prefix tells us the multiplier. For kilo, it increases. So instead of just a liter, we've got 1 times 10 to the 3rd liters. All I did was fill in the number here on the chart in place of the prefix. Now if I say that I have 1 kiloliter, and then I replace kilo with the prefix and write liter after it, I now have my unit equation. So if it doesn't make sense, start with the unit that has a prefix and write that out as a word. Replace the prefix with the number on the chart, and then you can put together your unit equation. So if I have 1 nanogram, what am I replacing the nano with? Yeah, it's one of those things that takes a minute. And there's like 80 ways to explain it. I try to go through as many as possible, and hopefully one will hit. It'll hit right. So if we're replacing the nano with what the value is from the table, what am I putting here? 1 times 10 to the minus 9 grams. So if that makes sense to you, then you're golden. As long as one way makes sense and you can go from something like this to a unit equation, you'll be just fine. Do we want to do another one just for practice? So there's 2 ways to write each unit equation. The top way that I wrote for number 1, you're flipping the sign. So you're starting with 1 meter, which is the basic unit, and then you're flipping the sign to define the unit with the prefix. It doesn't, if you're not familiar with the metric system, that top way will be a little more confusing. If it doesn't make sense to you, throw it out. If, however, writing the unit with the prefix first and then write equals and write what the number is for the prefix followed by the basic unit makes sense, like what we did with the 1 nanogram and the 1 times 10 to the minus 9, then do that. Does that help? Yeah. We are saying, so it's kind of like if you had a pizza. If you have 1 pizza and you cut it up the right way, you'll have 8 slices. It's the same thing, it's just using a slightly different unit. One whole pizza is the same thing as 8 slices of pizza. Okay. Other questions on this? Yes, exactly. Exactly that. So let's say that we had, this is a capital M, a megagram, right? 1 megagram. You read what it has here on the table. 1 times 10 to the 6. And then your basic unit is the gram. The mega is replaced by 1 times 10 to the 6. I'll give you guys another one to do. Decimeter and the meter. I'll give you a little bit. and then you can put your answer in the chat. So for each of these, you'll notice that there's a decimal number, like a regular number, over here. And then there's scientific notation. Just choose one. So a decimeter is equal to, you can either write 0.1 meters, which is there, or you could write 1 times 10 to the minus 1 meter. They're the same thing. Is it starting to make a little bit more sense now? We're going to be doing problems, so we'll practice this. Okay. Once we have a unit equation, we can write something called a unit factor. In the unit factor, you might also see called a conversion factor. Yes, I will give you the prefixes as a reference for exams. Unit factors, same thing as a conversion factor, and they look like fractions. You take your unit equation, which equations have an equal sign, so you can kind of keep them straight in your head. You take one of the numbers, write it as the numerator, take the other number, and put it in the bottom, which is the denominator. That's a unit factor. There's always 2 unit factors for every unit equation. The second unit factor is the reciprocal. So you flip it upside down. I'll give you a minute. I want you to try writing the 2 unit equations, or excuse me, the 2 unit factors for this second unit equation. I'm not going to ask you to put it in the chat because that's just annoying for you to type, and I don't want to do that to you. So I'll give you a minute or so, and then I will write it up on the screen. All right, I'll write them up on the board here. Board, screen, and same thing, I guess. Those are the 2 unit factors from that unit equation. How are we with writing unit factors? Good, meh, more practice? Let me know. When I ask for the unit factors, I will ask for both of them or say which one of these, is a unit factor from blah, blah, blah unit equation. So you'll know if you have to write both or just one. All right. So we're going to use the unit equations. Oh, we want more practice? I'm going to go through and do one of these metric conversions where we have to write a unit equation and some unit factors. When I get to the unit factors portion, I'll pause for a second and let you jot it down in your notebook what you think they're going to be, and then move on with solving the rest of the problem. Is that fair? Okay. So we learned these 2 skills so that we can solve some problems. In a lot of chemistry, you're going to end up converting from one unit to another. These types of conversions are going to come back around to us in the later chapters. So if you understand it now, when we come back around to about chapter 8, it won't be as difficult. So just a fair warning, don't push it out of your brain. Just keep it there, maybe push it back a little bit so you can bring it back up later on in the course. So you're performing an experiment that requires you to measure 56 milligrams of sodium bicarbonate. Your balance reports mass in grams. How many grams of sodium bicarbonate do you need? Report your answer in scientific notation. The relevant information: 56 milligrams of sodium bicarbonate, which we don't even care what chemical it is. And the question is asking how many grams, and it's got to be in scientific notation. I always, as my first step, if I have a paragraph of text like this, I write out the question. I write it kind of in shorthand using numbers, arrows, symbols, so that it keeps me focused on what I have to do. And right here, our question is 56 milligrams is equal to how many grams? That's what all that stuff was asking. Report in scientific notation, which I abbreviate as N. The information that we're given. Now you'll get this chart, and for each of these, I'll give you the information that you need to write out a unit equation and your unit factors. So here, we've got milli, and it is 0.001, which is the same as 1 times 10 to the minus 3. That's the information you would get on the chart. From there, we can write out a unit equation. If I have 1 milligram, how many grams do I have? You could put it in the chat. And with 56 milligrams, that's what we have in the problem. Right now we're trying to write a unit equation to relate milligrams to grams. So if I have 1 milligram, I have 0.001 grams, which is the same thing as 1 times 10 to the minus 3. I prefer using scientific notation just because 1, it's good practice, and 2, you have to write your answer in scientific notation, so it helps. But both of those answers are correct. 0.001 grams is the same thing as 1 times 10 to the minus 3 grams. So that's our unit equation. For unit factors, I'll give you maybe a minute to write those down before I do. So take a second and try to write down those unit factors from our unit equation, which we'll use 1 milligram is equal to 1 times 10 to the minus 3 grams. All right, I'm going to start writing them. We put 1 milligram on top, 1 times 10 to the minus 3 grams on the bottom, and then we flip it over. 1 times 10 to the minus 3 grams on top, 1 milligram on the bottom. So that's all the stuff that we can accumulate just from knowing what the question is. We have to relate milligrams to grams and convert our number of milligrams, 56, to a number of grams. So this is all the stuff that we can derive from this one line on the chart. Now we need to set up our equation. We know what 1 milligram is equal to in grams. Now we need to know what 56 milligrams is equal to. We take that 56 milligrams, and then we have a decision to make. We have two unit factors here. I'll label them A and B. We only need one of them to convert milligrams to grams. The goal here is to choose the unit factor that will cancel out milligrams and leave us with grams. Milligrams is already in the numerator, which is the top. We need to choose the unit factor with milligrams in the bottom or the denominator so that they'll cancel out. Which one should I use, A or B? Exactly. I should use B. Before I touch my calculator, I'm going to make sure that my units make sense. I have milligrams in the top and the bottom, so I can cancel out the milligrams. That leaves me with grams. And when I look at my question, that's what I need. So now you can go ahead and pick up your calculator if you have one, and you can put this into your calculator. The way that you're going to enter it is 56 times, and you may need to use parentheses, 1 times 10 to the minus 3. This part, you'll need the EXP or the EE button on your scientific calculator. Give that a shot, and then put your answer in the chat. And if this was multiple choice and that was your answer, I would have got you. Why? Scientific notation. So your calculator will probably say this. But remember, look back at the question. Report your answer in scientific notation. So it would be 5.6 times 10 to the minus 2. Remember, for that coefficient, it's got to be at least 1, but less than 10. So it can't be 56. It's got to be 5.6. So I've got a few more of these metric conversions, and I've also got a couple of metric English conversions. So we'll go through another problem. I'll ask you some more questions. And then after we do that problem, you can try one on your own. So this question is a bit simpler. How many milliliters are in 1.82 liters of water? So again, we're using milli. And again, we have to report our answer in scientific notation. So there's our question. 1.82 liters is equal to how many milliliters? Reported in scientific notation. With our given information of what milli is, what's our unit equation? I'll give you a minute. You can put your answer in the chat. And if you're stuck, that's okay. Let me know that you're stuck. So the full unit equation is going to be 1 milliliter equals 1 times 10 to the minus 3 liters. That's the full unit equation. Don't just give me this part. You have to give me everything. It's an equation, so it's got to have an equal sign. For our unit factors, we just write out the fractions. Let's set up the equation. Again, we've got a choice to make. Which of these unit factors will get us from liters to milliliters? Remember, we need to have liters in the denominator, so we need to use A. So you can't just always choose the second one. You have to look at the units and make sure they cancel. There's liters on the top, liters on the bottom, and we're left with milliliters at the end. Does everybody understand that now? Okay. So now you need to put this into your calculator. You've got 1.82 times 1 divided by 1 times 10 to the minus 3. So when a number is in the numerator, you're multiplying. When a number is in the denominator, you're dividing. Your calculator will probably tell you this, but we need to write it in scientific notation. Yes. So No, it only cancels out the unit. We always keep all the numbers, but the units we can cancel. So it's kind of like in algebra. I'll give you an example. If I had 1.82x times 1 over 0.001x, those x's will cancel. But I've still got the numbers. I've got 1.82 over 0.001. So we still have to do the multiplication and division. We're just changing the units. Is that a little more clear? Shh. Yeah, that's right here. So if we're having issues with using the calculator, ask Google, but you can also stop by office hours. And we had office hours today at 11 o'clock. It was from 11 to 1. But if you've got questions now that we've got class, you can always send me a course message, and then we can set something up for another day. So talk to me. From the last question to now, do we feel better, worse, or about the same with doing these conversions? Don't be afraid to be honest. Okay. Because we've got plenty more practice to go. So a few of y'all are feeling a little better. Some people are about the same, which isn't necessarily a bad thing. So let's keep going. The best thing to do for these problems is practice. Now we're going to work on a couple of metric to English conversions. It's going to be the same exact process, only you don't need to come up with a unit equation because you can't. I give it to you. This is something you can't just look at the chart. So let's say you happen to be in Canada and it's, post-COVID time, right? So you can travel and not worry. The speed limit on a road in Canada is listed as 150 kilometers per hour. Express the speed limit in miles per hour. And I told you 1.61 kilometers is the same thing as 1 mile. So for our question, 150 kilometers per hour is equal to question mark miles per hour. We already know 1.61 kilometers is equal to 1 mile. That's our unit equation already given. What I want you to do is write out your unit factors and try to put together the equation you would use. So that means choosing the unit factor that will get you from kilometers per hour to miles per hour. I'll give you 5 minutes and then I'll check back in. Alrighty. If you haven't finished, that's okay. If you're stuck, that's okay. We'll get you unstuck and hopefully you'll understand why you got stuck and how you can move forward. So the first thing we need to do is fill in those unit factors. Those are the fractions. So there's that. But now we've got to set up the equation. Which unit factor do we use, A or B? We're trying to get rid of kilometers and replace it with miles. Yes. 1 mile for every 1.61 kilometers. Did anybody get an answer? And if not, you can take the opportunity to put this into your calculator. What you'll enter is 150 divided by 1.61. That's right. And so your calculator is going to tell you 93 point something something something. But we need to consider sig figs here. We haven't really need to think about it. Yeah, I mean, it's a whole number. Yeah, we think about speed as a whole number, but we also have to think about sig figs. With the metric to English and English to metric conversions, you'll have to consider sig figs. The given information, we've got 150 kilometers per hour. That's got 2 sig figs. So that means our answer has to have 2 sig figs, and it does. I've got one more for you. I want you to try this one on your own. I'm not going to set it up for you. It's a metric English conversion, so you've already got the unit equation right here. I'll give you 10 minutes this time. I'll probably check in around 8 minutes to see how we're doing and if we need the other 2 minutes. And then, max 10 minutes, I'll start going over the problem. Okay. Seems that several of y'all are done. So I'll start going over it. Then you won't have to wait in suspense any longer to see if you're right. We know our unit equation. So to write our unit factors, we just write the fractions. To set up our equation, as usual, we've got to choose which unit factor we're going to use. We want the grams to be in the bottom so we can cancel it out. Your calculator will tell you 25.9. But again, sig figs. We've got 2 sig figs here. So it should be 26 ounces. Now, a lot of you put 25.9. And if this were a chapter check-in or an exam where you're showing your work, you would get most of the credit. I don't take off a lot of points for sig figs. But make sure that you have your units, because I do take off points for that. And even that, not a lot. I care more about the process. So if you showed me all of this, but you got, say, the wrong answer here, you put in, 704 instead of 740, so you got a weird number for your ounces, you would still get most of the credit for that problem. So good job for y'all who shared and you got it right. Even if you didn't get the sig figs right, getting here, good job. Are there any questions? Once again, Blackboard, for some reason, every time I have a 2 o'clock class, it decides to go black. But this was about the time that we were going to take a break. So, take 10 minutes, and when you return, everything will be right as rain. So 10-minute break, we'll be back at 3:22. Again. So we just finished up metric English conversions, which are very similar to the metric conversions. We use one unit factor, which we derive from one unit equation. But what if we have to go through two conversions? That's a two metric conversion. I'll go through this problem, and then we'll do just like before and kind of build where you give some input, and then we build up to you doing a problem on your own. How many nanoseconds are in 5.21 kiloseconds? Report your answer in scientific notation. The question, 5.21 kiloseconds is equal to how many nanoseconds? This is a little bit different. We have a prefix on both sides of the equation here. So we can't just write one unit equation. We actually have to write two. So our goal is to go from kiloseconds to seconds, and that will be our first unit equation. Then we'll go from seconds to nanoseconds, and that will be our second unit equation. So two metric conversions are just like doing two of the single conversions that we were doing. We're going to put two unit factors back to back. So the first unit equation, we're relating kiloseconds and seconds. One kilosecond is equal to 1 times 10 to the third seconds. We just fill in the number for kilo and put second. Now we've got unit factors. 1 kilosecond over 1 times 10 to the third seconds. And then we simply write the reciprocal. We're going to go through this whole process again for the second unit equation. We're relating nanoseconds to seconds. If I have 1 nanosecond, that's equal to 1 times 10 to the minus 9 seconds. My unit factors, I just write the fractions. Now we're setting up that equation. We need 2 unit factors this time, and I'm going to write out what our plan is. So we're starting with kiloseconds, and with our first unit factor, we should be converting to seconds. With our second unit factor, we should be converting to nanoseconds, and we'll be able to check that off along the way. You know the game. We've got unit factors to place. The first one, we need to get rid of kiloseconds and replace it with seconds. So which one, A or B, is going to cancel kiloseconds? B. Now we've got to do that same process again. Only this time, we're trying to cancel out seconds and get to nanoseconds. Am I using A or B? Yes, y'all are getting it. I certainly encourage you to go through and cancel and make sure that you're ending up with the units at each step that you want to end up with. The first part of our equation, we're converting from kiloseconds to seconds. So we should be canceling one on the top and one on the bottom, and we're left with seconds, just like in our plan. Then we should be canceling these seconds to end up with nanoseconds at the end, and we do. For putting this into your calculator, you've got 5.21 times 1 times 10 to the third divided by 1 times 10 to the minus 9. Try putting that into your calculator. Let me know what you get. Let me know if you're having trouble putting it into your calculator. You should get 5.21 times 10 to the 12th nanoseconds. Talk to me. Do we have problems with putting it into the calculator? Still trying to catch up on notes? What's going on? So I wrote that out right here. 5.21, yeah. Okay, when I do the calculator, how to put it into the calculator, I'll write it in a different color. Duly noted. So even though I wrote the answer up there, give it a shot and see if you get the same thing. Okay. Yeah, so if you got the same thing, then you're on the right track with using your calculator. So that's good news. Let's do the next one. Are we ready to move on? Because we're just going to keep practicing with these. Okay. So now we've got an experiment that requires 25 picograms of enzyme. How many milligrams of enzyme do you need? Report your answer in scientific notation. Pico is 1 times 10 to the minus 12. Milli is 1 times 10 to the minus 3. That's just for your reference. If you want to jump ahead of me and work on this problem on your own, go for it. If you still want to keep the training wheels on, stay with me. So we'll write the question out. We've got 25 picograms that we need. What is that in milligrams? And we have to report it in scientific notation. It's the same thing here. You see a prefix on both sides of this question, picograms to micrograms, or excuse me, milligrams. That means you have to do 2 conversions, and that means we'll need 2 unit equations. For the first unit equation, we're going to relate picograms and grams. I want you to take a minute and figure that out. We're just going to fill it in from the number that we see above. It's 1 times 10 to the minus 12. The unit factors are just the fractions. I'll do the second unit equation in a different color so that it stands out a little bit. And I'll keep the colors going the same way throughout when we're writing our equation as well. In the second part, we have to go from grams to milligrams. If I have 1 milligram, that's the same thing as saying 1 times 10 to the minus 3rd grams. These are my unit factors. Now we set up the problem. Our starting value is 25 picograms. We're going to fill in a unit factor from our first unit equation, and we'll fill in one from the second unit equation. What am I filling in for the first one if we're trying to go from picograms to grams? A or B? Y'all are ready. It was like you had your finger hovering over the the B. And which one am I going to use to go from grams to milligrams? A or B? I'm going to use A. Now we need to cancel out these units and end up with milligrams. We get to grams first. Then we get to milligrams. And the way that you need to write this into your calculator, I'm going to do that in purple over here. 25 times 1 times 10 to the minus 12. And you divide that, I'm going to do the line for dividing, by 1 times 10 to the minus 3. So that's 25 times 1 times 10 to the minus 12 divided by 1 times 10 to the minus 3. Let me know what you get. So for those of you who got something times 10 to the 14, I think you entered something wrong. And it should be 2.5 times 10 to the minus 8. And that's milligrams. So if you didn't get this, then recheck what you did in your calculator. So for those of you who may have gotten the wrong answer or slightly wrong answer, let me know if you figure out what your issue is with the calculator. Otherwise, we can talk about it right after class. So how do we feel about these two metric conversions? Meh. Good. Wish they'd go away. It takes practice. I'll be posting some practice problems for you. The practice problems, you do not need to give them to me. You just can practice on your own, and then you can come to me for help. So I'll give you some practice as well. So we've got 2 more concepts to cover. The first is compound units, which is very similar to the two metric conversions. It's similar because we have to use two unit factors that we get from two different unit equations to go from one set of units to the other. The difference is instead of just going from, say, picograms to milligrams, we're taking two units, compound units like miles per hour or gallons per minute, and converting it to something else like meters per second. In this problem, we're talking about the average low-flow shower head. It flows approximately 3 gallons of water per minute. What is the flow of water in liters per second? And I give you one of the unit equations that you'll need. That unit equation you will not be able to look up on the table. Gallons are not part of the metric system. Let's rewrite our question. We have 3 gallons per minute. And we want to know, what is that in liters per second? For our first unit equation, we need to go from gallons to liters. And we've already been given that unit equation. 1 liter is equal to 0.26 gallons. Write out your unit factors. So that's the first part, right? Gallons to liters. The second part of this is to convert the minutes, the per minute, to per second. Now, this isn't something that is in the chart, but it is something you should know. How many seconds are in 1 minute? Good. So for those of you who might still be getting something weird in your calculator, you can take a picture of it and you can send it to me in course messages and I can help you out that way. Or you can just stay after for a minute and we can chat for 5 minutes. Up to you. Either way, we can get it done. We write our unit factors from this unit equation. Then we put together our equation, just like always. I'm being very intentional about how I'm writing these parentheses and trying to line everything up. Because I want it to be clear, what is the denominator, what's the numerator. The first part of this, we're going from gallons to liters. Which unit factor am I going to use, A or B? we need to use A. We're canceling out those gallons, so we need to have gallons in the top and gallons in the bottom. It's going to be in the bottom of our unit factor. This time we're doing something a little bit different. We need to cancel out minutes, but minutes are in the bottom right now. They're in the denominator. To cancel out minutes, we need to choose the unit factor that has minutes in the numerator. So which one is that, A or B? Yeah, we have to use A. That's going from the per minute to per second. Let's make sure our units actually cancel the way we want them to. We've got gallons in the numerator canceling with gallons in the denominator. We still want the numbers, we're just canceling the units. We're left with liters on the top. Good. Then we've got minutes in the denominator canceling with minutes in the numerator of our unit factor. And we've got seconds in the denominator. So those are our units, liters per second. If you're going to enter this into your calculator, you need to do 3 divided by 0.26 divided by 60. Try that out. Let me know what you get. So you should get somewhere in the ballpark of 0.19. But remember our starting information, 3 only has 1 sig fig. So our answer should have 1 sig fig, 0.2. Again, if you got 0.19 and you put your units, you will get most of the credit. The sig figs, that's kind of, the cherry on top. Questions about this one? Are we ready to move on to another compound units problem? Let me know which one. Questions? Or if you're ready to move on. Okay, it's a little bit hard to hear you. Okay. Are we voting to move on then? All right. Then we've got one more compound unit problem. And then we're moving on to a kind of unrelated topic. We're back in Canada because I'm dreaming of going somewhere other than my home. Thanks, COVID. The speed limit on a road in Canada is listed as 150 kilometers per hour. Express the speed limit in meters per second. I always rewrite the question. Now, before we get all the way down to the answer, how many sig figs should we include in our answer? 2 sig figs. 150 only has 2 significant figures. So let's just make that note. Now, this time we're going from kilometers to meters and hours to seconds. So we're really going to be using 3 unit factors. I'll make a list of them over here. The first one will deal with kilometers to meters. The second one from hours to minutes. And the third one from minutes to seconds. If you feel confident or you want to try it on your own, go for it. Otherwise, you can stick with me and we'll walk it through, and I'll ask for some input as we go along. We've done this quite a bit now, but I'll still write it up. Kilo is 1 times 10 to the third. If we're going from 1 kilometer to the number of meters, it's 1 times 10 to the third meters. Our unit factors are the fractions. Now we're moving on to unit equation 2. We're going from hours to minutes. I've got 1 hour. How many minutes is that? 60. Again, we write out the unit factors. You're going to get real good at writing out those unit factors and the unit equations. Our third unit equation is going to be similar to what we did in the last problem, going from minutes to seconds. If we've got 1 minute, we have 60 seconds. Whew, I just wrote a thesis over here. We ain't done yet. Time to set up the equation. We're starting with 150 kilometers per hour. And again, be very intentional when you're writing these unit factors in your units. You want to keep your numerators and denominators straight. We're going to go full color on these because there's a lot going on. For the first unit equation, we're going from kilometers to meters. A or B? We know this is the A column. This is the B column. Which unit factor are we using? We're going to use B. We want the kilometers in the denominator so that they cancel. What about the next unit factor? We're going from hours to minutes. A or B? We're going to use A because hours are currently in the denominator. We need hours in the numerator of our unit factor to cancel it out. And finally, the third unit factor set. Are we using A or B? And this is from minutes to seconds. We're going to use A again because minutes are currently in the denominator and we need to put minutes in the numerator so we cancel it out. So we've gotten rid of kilometers and we've got meters. Check. We've gotten rid of hours and we're now at minutes. Good. Then we get rid of minutes and we've got seconds. And we have meters on the top, seconds on the bottom. To put this into your calculator, 150 multiplied by 1 times 10 to the third divided by 60 divided by 60 again. In the interest of time, I'll just or y'all are fast. Yeah, y'all are fast. Your calculator is going to say 41.6666 repeating. But we need the 2 sig figs, so that's 42. And our units are meters per second. So you'll have something like this as part of your chapter check-in, along with one other question. If you haven't looked at it yet, it's there in the Chapter 2 folder. We're going to move on to the last concept, which is a little bit easier. Percentages. You've been dealing with percentages forever because you've been in school forever, right? So we're going to go over this problem, make sure we're all on the same page with percentages, and then we'll do a couple of extra problems just to make sure we're good. Then we'll be done. A student scored 87.5 out of 115 possible points on an exam. Calculate the student's grade as a percentage. Percentage is calculated as a part over a whole times 100%. In this case, what is our part? So y'all got the answer already, so you obviously already know what it is. The part is 87.5. The whole is 115. You multiply that by 100%, and you should get, if we're using 3 sig figs, like here, 76.1%. With these types of questions, I will usually tell you round to 2 significant figures or round to 3 significant figures. We're not going to be too concerned with that right now. Does everyone understand how to calculate a percentage straight up? If you don't, that's fine. And if you're embarrassed to say it, you don't have to be. But you can tell me in the private chat or right after class. You can come to office hours, that kind of thing. So please don't be left behind. I'm here for everybody. Let's do a slightly different take on that. Let's say that we know a student earned a grade of 92% on their second chemistry exam. If the exam was graded out of 115 points, how many points did the student earn? Starting with our same part over the whole times 100%. And go ahead and solve this and put your answer in the chat if you feel so inclined. We can fill in all of this except for the part. The part, that's the points. Now I'm going to walk it through step by step. And unless you tell me to, I'm not going to go into a lot of detail. But we need to isolate that part on one side and get all the numbers on the other side. Multiply by 115 to get rid of that 115 on the one side. We divide by 100%. We get rid of that 100%. And now we've just got 115 times 92 divided by 100 is equal to our part, which is the points earned. Your calculator answer, I believe, is 105.6 or something like that. 105.8. Yeah, that's 105.8. For here, I'm not going to go hard on significant figures because typically speaking, for an exam, you're not going to be doing any rounding. Sig figs would give this person a huge jump. If I had 105.8, which let me write that 8 a little bit better. If I were to report that with 2 sig figs, what would it be? $110. Now I'm sorry, y'all. I don't do sig figs when I do your grades for exams. So with 2 sig figs, that's what it would be. Okay. So that's a little bit more complicated than just solving a percentage problem straight up. Are we still good? If not, let me know. We may have time for one more. So how about this? We'll do one more problem type, and then, time permitting, we can, as a class, go back and do another type like this. Otherwise, if you have 5 minutes after class, we can do another one just like this. Okay. With percentages, technically you will worry about significant figures always unless told otherwise. When I'm giving you a homework question or an exam question, I will be specific about what I'm looking for. I will say something like, report your answer with 3 significant figures, or I'll say, you report your answer using the correct number of sig figs, which will kind of clue you in. Use the sig fig rules that you know. Right now, we're just trying to iron out and make sure you understand the concept. The sig figs, that's kind of the icing on the cake. The final type of question for percentages that we'll be doing is one where we have a percentage and we use it kind of like a unit factor. I did a problem similar to this in the video. The earth contains 4.7% iron. How much iron is in a 71 gram sample? 4.7%. That's the same thing as saying 4.70 over 100. That's what a percentage is. I can assign units to this, like grams of iron out of a 100 gram sample. Because again, we're just writing what this percentage means. If I have 100 grams, 4.7 of those grams will be iron, because that's the percentage of iron in the Earth's crust. If I want to figure out how many grams of iron I have in a sample that weighs something other than 100 grams, I can simply take that sample size, 71 grams in this problem, and multiply by this unit factor, because that's exactly what it looks like. We're doing a conversion from grams of sample to grams of iron. When you do that math, you should get 3.337. But with sig figs, we've only got 2 sig figs in our sample size. So it's 3.3 grams of iron. The key to this problem is recognizing that you can write 4.70% iron as a unit factor. We will start next week's class by doing a do now that covers a percentage problem and some of the metric conversion stuff we've been doing. If this doesn't 100% make sense to you, that's okay. But how do we feel about percentages overall? Okay. Then what I will do is I'll run through the reminders real quick, And then for those of you who want to stay to do another problem type where you have to figure out the part, you can stay for that. That'll be another 5 minutes. Otherwise, you'll be free to go after I give you these reminders. So you've got a Chapter 2 check-in and syllabus quiz due Sunday, which is February 7th. That's always by 11:59 p.m. Both of those things are located in course content. The Chapter 2 check-in, you go to course content, and then go to the Chapter 2 folder. That's where you'll find the check-in. It is a Blackboard assignment. I've put up the PDF version and the Word version. You need to show your work. So if you want to write it out by hand and take a picture of your notebook and upload that as a PDF, totally fine. If you want to type out your work, or if you have a tablet, you can write it out or type it out in the Word document and submit that. Whichever one, doesn't matter to me, as long as you show all of your work. The syllabus quiz is simply in the course content folder. Use the syllabus and the information that I gave you in our first session together, where we talked about how to use Blackboard, how to contact me, and all that kind of stuff. Use those two things to complete that quiz. It will be added to your exam grade. It's worth 50 points. It will be the easiest 50 points you ever earn. If there's a question, go right ahead. It's multiple choice and it's on Blackboard. So you just go on and take it on Blackboard. You don't even have to use Respondus. You will see your grade right away because it's all multiple choice, multiple answer, nothing complicated. You will see your grade right away. Okay. Mastering Chemistry for Chapter 2 is due on the 14th, which unfortunately is Valentine's Day. So I'm sorry. If you love your significant other, tell your boo, look, I'm going to be busy now. I'm going to do my Chapter 2 homework so I can get it done before Valentine's Day we can celebrate. I apologize. I'm going to be working too, so you ain't alone. Work on it early. Exam 1 is available February 17th, which is a Wednesday. We'll talk more about the exam next week. But I just wanted to put that on your radar. And it's going to cover the prerequisite science skills and Chapter 2. If you don't have any questions for me, you're free to go. Otherwise, you can stick around for another 5 minutes and we can do another problem. No, this quiz, the exam will require Lockdown Browser. The syllabus quiz does not. Yes. Okay, we can definitely do that too.